Assalamualaikum and hi. So today our group is going to present about bipolar junction transistor, which is common emitter, which is common collector configuration. So before we start, let me introduce our group members. First, my name is Masrah Hazra binti Muhammad Kamal. Next, we have Nur Izzati binti SHA'ARI. Third, we have Rabiatul Maisara binti Nordin. And lastly, we have Nurul Shazwani binti Razali. So first, I will begin our presentations by introducing the bipolar junction transistor, or known as BJT. A BJT is three-terminal semiconductor device that is widely used in analog electronic circuits. Its two main functions are signal amplifications and electronic switching. One important feature of a BJT is that a small base current can control a much larger collector current. As shown in the figure on the left side of the slide, there are two types of BJTs. The first is the NPN transistor at the top and the PNP transistor at the bottom. These figures also shows the three terminals of a BJT, namely the emitter, base and collector. A BJT has three terminals. First, the emitter, which emits charge carriers. Second, base, which controls the transistor operations. And lastly, collector, which collects the charge carriers. There are two types of BJTs, namely NPN and PNP transistor. In an NPN transistor, the base is positively biased with respect to the emitter, and electrons are the majority charge carriers. And next is in a PNP transistor, the base is negatively biased with respect to the emitter, and holes are the majority charge carriers. Although both transistors perform the same basic functions, they differ in the direction of current flow and their biasing condition. Next, let's look at the transistor configurations. A transistor configuration refers to the transistor terminal that is common to both the input and output circuits. As shown in the figure on the right side of the slide, there are three basic BJT configurations: common base, common emitter, and common collector. Each configuration is named according to the terminal that is shared between the input and output circuits. There are three basic BJT configurations. First, common base configuration, which is mainly used in high frequency circuit. Second is the common emitter configuration, which is commonly used in general purpose amplifier circuits. Third is common collector configurations, which is widely used in buffer circuits. Different transistor configurations are used because each one provides different electrical characteristics such as voltage gain, current gains, input impedance, and output impedance. Therefore, engineers select the most suitable configurations based on the requirements of the electronic circuits. In these presentations, we will focus on the common emitter and common collector configurations, which will be explained in more detail by my other group members.
So, I will explain the common emitter configuration. The common emitter configuration is one of the most widely used transistor configuration. In this circuit, the input signal is applied between the base and emitter, while the output signal is taken between the collector and emitter. The emitter is connected to both input and output circuits, which is why it is called the common emitter configuration. The input characteristic shows the relationship between the base current and base emitter voltage. As the base emitter voltage is increased, the base current also increases. For the output characteristic, it shows the relationship between the collector current and collector emitter voltage. The transistor has three operating regions, which is cut-off regions, active regions, and saturation regions. For amplification, it operates in the active regions. When an AC input signal is applied to the base, a small change in the base current controls a much larger collector current. This produces a larger output voltage, giving the amplifier a high voltage gain and current gain. The output signal is also inverted by 180 degrees, which means it is opposite in phase to the input signal. The common emitter configuration provides a high voltage, current gain, and power gain, making it the most widely used transistor amplifier. However, it also has some disadvantages, such as 180 degrees phase inversion and sensitivity to temperature changes.
Now, I will explain the common collector or CC configuration, which is known also as the emitter follower. In this configuration, the collector terminal is common to both the input and output circuit. The input signal is applied to the base while the output is taken from the emitter through the emitter resistor, which is RE. It is called an emitter follower because the output voltage at the emitter closely follow the input voltage at the base. The only difference is that the emitter voltage is approximately 0.7 volt lower than the base voltage due to the forward bias base emitter junction of the silicon transistor. Compared to the common emitter configuration, the common collector configuration does not provide significant voltage amplification. Instead, it is mainly used to provide high current gain and to act as a buffer amplifier. Now, we will move to the input and output characteristic of CC configuration. The graph on the left shows the input characteristic of the common collector configuration. It illustrates the relationship between the base current IB and the base collector voltage VBC, while keeping the collector emitter voltage constant. As the input voltage increase, the base current also increase. This behavior is similar to the forward bias diode because the base emitter junction is forward biased. The graph on the right shows the output characteristic, which describe the relationship between the emitter current (IE) and the emitter collector voltage, while the base current remain constant. When the base current is zero, the transistor is in the cut-off region, so almost no emitter current flow. As the base current increases, the transistor enters the active region, where it operates as an amplifier. If the base current increases further, the transistor reaches the saturation region, where further increase in current produces very little change in the output. One of the most important applications of the common collector configuration is impedance matching. This configuration has high input impedance and low output impedance. High input impedance means it draws only a small amount of current from the input source, preventing the source from being overloaded. Low output impedance allows the circuit to supply sufficient current to the load efficiently. Since the collector terminal is common to the both an input and output circuit, the current gain is approximately equal to the ratio of the emitter current to the base current, which is relatively high. However, the voltage gain is approximately 1, meaning the output voltage remains almost the same as the input voltage. Because of this characteristic, the common collector configuration is widely used as a buffer amplifier between a high impedance source and low impedance load. And now we are moving to the advantage and disadvantage of CC configuration. The common collector configuration has several advantages. It provides high current gain, high input impedance, and low output impedance, making it suitable for driving low impedance load. It is also produce no phase inversion, so the input and output signal remain in phase. In addition, it is excellent for impedance matching and signal buffering between different circuit stages. However, it also has some limitation. The voltage gain is approximately 1, so it cannot provide significant voltage amplification. Therefore, it is not suitable for applications that require high voltage gain. Instead, it is mainly used to transfer signal efficiently while maintaining their original voltage level.
Okay, so this table compares the characteristic of the common emitter and common collector transistor configuration. First, the common emitter configuration provides a high voltage gain, making it suitable when a large increase in signal voltage is required. In contrast, the common collector configuration has a voltage gain close to 1, so it does not significantly amplify voltage. However, the common collector has a much higher current gain and a lower output resistance. This makes it ideal as a buffer because it can drive low resistance load without weakening the signal. Another important difference is the phase relationship. The common emitter output is inverted by 180 degrees, while the common collector output remains in phase with the input. Therefore, the common emitter is mainly used for voltage amplification, where the common collector is mainly used for buffering and impedance matching. So for real-world application, first for common emitter, audio amplifier. The common emitter configuration is widely used in audio amplifier because it provides high voltage gain. It increases weak audio signals so they can be processed or amplified further before driving a speaker. Second, signal conditioning circuit. Signal conditioning circuit often use the common emitter configuration to amplify weak sensor signal before they are processed by electronic system. This improves measurement accuracy. So next, for common collector, first, buffer amplifier. The common collector configuration is commonly used as a buffer amplifier. Although it does not increase the voltage, it insulates one circuit from another and prevents signal loss when driving low resistance load. So next, sensor interface circuit. The common collector configuration is also used in sensor interface circuit. Many sensors produce weak signal that can be affected by connected circuit. The common collector acts as a buffer, ensuring the sensor signal remains stable before entering a microcontroller. So, lastly, the common emitter and common collector are two important BJT configurations that have different functions. The common emitter configuration is mainly used for voltage amplification, while the common and collector configuration is suitable for buffering and impedance matching. By understanding their characteristics and application, we can choose the most suitable configuration for different electronic circuit design. So that's all from our groups. Thank you.